I want to wrap up our discussion on future and present value with an example here of both of them being used together. So what we have here, Sam is currently 31 years old, and the goal is to have $60,000 at age 53. At 53, $25,000 is going to be used to make a down payment on a house. The remaining $35,000 will be invested for retirement at age 67. From 31 to 53, Sam will invest at 8.7% compounded monthly, and 53 to 67, the investment will be at 6.2% compounded quarterly. How much should Sam invest at 31, and what will the balance be at age 67? So here we are going to do a little bit of a number line. We're starting out at age 31, going to age 53, and then 67. In this stretch from 31 to 53, it's going to be 8.7% compounded monthly. Time there, if we subtract 53 minus 31, it's going to be 22 years. 53 to 67, we're going to get 6.2% compounded quarterly. And of course, if we subtract there, 67 minus 53 gives us 14 years. And of course, the goal, we're going to have $60,000 at 53. $25,000 of that goes towards the house, and $35,000 of that goes forward into the retirement, moving on to age 67. So let's start by finding the present value. The first part of the problem is how much should Sam invest at age 31? That'll be the present value with a future value of $60,000. That's going to work then with a rate of 8.7%, so 0.8087. Time of 22 years. And of course, n, since that's monthly, will be 12. So that present value is that future value of $60,000 divided by our compound interest factor, 1 plus a rate of 0.087 divided by n of 12 to the power of n of 12 times years of 22. So we type this in, giving us a present value of $8,910.67. So if Sam puts that much away at age 31, Sam will achieve that goal of having $60,000 at age 53. Now the next step is we want to know how much will Sam have at age 67. This is going to be a future value calculation. We were looking for the future value here at 67. Given the present value at 53 is going to be $35,000. Now for this part, we're going to have a rate of 6.2%, so 0.062. Time is going to be 14 years, and n for this one is going to be 4 because it's compounded quarterly. So let's find that future value of $35,000. It's going to be times, because it's future value, 1 plus our rate of 0.062 divided by 4, because it is compounded quarterly, to the power of n is 4 times 14 years. Giving us a future value of $82,821.67. So Sam will have $82,821.67 at age 67 off of that single investment. So starting with this $8,910.67 at age 31, Sam will accomplish the goal of having $25,000 to use for that down payment on a house, and investing what's left over, we'll have $82,821.67 at age 67. Now the other problem I wanted to do to tie everything together has to do with that effective rate. To do that, we're going to look at this example here. Pat invests $5,000 at 9.3% compounded monthly for 3 years. Now we're going to find the future value of this first. The future value will be the $5,000 present value times our compound interest factor of 1 plus 9.3% is 0.093 divided by compounded monthly is divided by 12 to the power of 12 times 3. That's going to give us a future value. So that future value is $11,437.03. So at the end of the 3 years, Pat should have $11,437.03. To explore there's a mistake in this calculation. If you can see what it is, when I typed it into the calculator, I put divided by 4 there. So let's re-enter that. That is not the correct future value. Take that out quick. 5,000 times 1 plus 0.093 divided by 12, not divided by 4. Close parentheses to the power of 12 times 3. Gives us a correct future value of $6,601.93. So that looks much better for a future value. Now, let's go back to what we were talking about for effective rates. For effective rate, or that would be the equivalent simple interest rate for up to a year. If the term of the investment is less than a year, we use the actual term. If it's more than a year, which it is here, this is 3 years, we use 1 year. So we're going to find the future value here for 1 year of that $5,000, still at 9.3%, still compounded monthly. Now it's going to be the power of 12 times 1, which is just going to be 12, right? So 5,000 times 1 plus 0.093 divided by 12 to the power of 12. We get a future value at the end of the first year of $5,485.34. Of that amount, compound interest is found by subtracting that present value, that principal of $5,000. So that means there's $485.34 in compound interest. We'll use that to find an effective rate. To find the effective rate, we put that $485.34 in for I in the I equals PRT formula. Our principal is the $5,000. We're looking for the rate and our time is just 1 year. So 5,000 combined with the 1 is still just 5,000. So we're just going to divide by 5,000 to solve for the rate. So $485.34 divided by $5,000 is 0.097068. That's our rate. As a percent, that would be 9.7068%. Now I'm going to leave it all the way out to that. And what this is saying is this is the equivalent annual rate. Equivalent to that 9.3% compounded monthly each year. How can I prove that? Well, let's use that as an annual rate for 3 years. So it's still going to compound because we use this rate each year. There's just no compounding within the year. But it does, they do have to figure in the interest at the end of the year each year. So it does compound at the end of the year. There's just no compounding within the year. The effective rate is for a 1 full year at a time. So let's use that rate to find a new future value of our $5,000. Based on that rate, so 1 plus 0.097068 divided by 12, sorry, not divided by 12, it's divided by 1, because that's an annual rate, so it's only going to be figured in once a year, to the power of 1 times 3. We're still going for 3 years. So that rate takes us through 1 year at a time, but we do have to compound it for each of the 3 years. So we'll take 5,000 times, parentheses, 1 plus 0.097068 divided by 1, close parentheses, to the power of 3. And we get 6601.93. Well, that number should look familiar because that is the exact same amount that we had in our original future value calculation for the 9.3% compounded monthly. So what that effective rate means is that is the rate you could use if you only compounded your interest once a year. That's the effective annual rate. So 9.3% compounded monthly is equivalent to our 9.7068% compounded annually. That is the full meaning of that effective rate. It's that equivalent annual rate. That is pretty much it for future and present value. We'll move on to annuities in our next set of videos.